Right. In this session, we are going to discuss how hydrogen bonds are formed. From that, we are going to move into the boiling point variation. Boiling point. Actually, this includes also the melting point variation. Boiling point, melting point variation. Actually, this includes everything, people. When someone tells you to classify the melting point or boiling point of these people, like again, මෙහෙම කලවමක් දෙනවා SiO2, Br2, CO2, and then NH3, H2O. Likewise, they are going to give a lot of compounds like this in different, different. අයියෝ. Wait. Okay, no, okay. I think this will happen for some amount of time. So don't worry about it. Once or twice it might happen. Plus came back, okay. Yeah, plus came back. And I'm going to start, right? So like this, they are going to give different compounds into your question and they are going to ask you, arrange them in the increasing order of melting or boiling point. They will also include sodium chloride. මේ වගේ compounds ටික ඔක්කොම දානවා. හරි. Now you should be able to compare the boiling point or melting point of all these compounds. එතකොට අර NaCl, MgCl2 එහෙම නෙමෙයි. ඔක්කොම SiO2 and NaCl. අන්න ඒ වගේ, right? So we are going to talk about that. Before going into that concept, we are going to learn how hydrogen bonds are formed and how to identify whether a hydrogen bond is forming or not. So tell me, people, if there is a mixture of acetone, in an acetone mixture, will hydrogen bonds form? In an acetone mixture. In an acetone mixture, will hydrogen bonds form? Tell me, everyone in the meeting, tell me, will an acetone mixture, acetone කියන්නේ මේක CH3, C double bond oxygen, CH3 මේක. This is acetone. So tell me, will this form hydrogen bonds? Everyone, speak. Yes. Gafur, you were not there in the previous one, right? What were you doing? We missed you. Huh? You were not there in the previous meeting. We are angry with you. No, right. Very good. Everyone is telling no. So that means you know something, right? Yeah. You know something. And then I'm going to ask you, what about aqueous solution of acetone? What about an aqueous solution of acetone? Acetone mixed with water. What about that? Acetone mixed with water. What about that? Yes, it's going to form, right? It's going to form. Right. Let's see the concept. How to identify whether they are forming hydrogen bonds or not. Okay, under how hydrogen bonds are formed, there's only a big topic, people. So I have to write everything under it. Right there. There are two conditions needed. In order to form hydrogen bonds. There are two conditions needed in order to form hydrogen bonds. Okay, right. First one, there should be hydrogen attached to fluorine, oxygen, or nitrogen. Right? This is the first. Why is this happening, people? All of a sudden, right? Now it's 4 times, I guess. Doesn't matter. Let's continue. Hydrogen attached to fluorine, oxygen, nitrogen. That's the first thing. Second one, you need lone pair on oxygen, fluorine, nitrogen, or you call it fluorine, oxygen, nitrogen. You need a lone pair on these compounds. So, who are the compounds which satisfy both of these? Ammonia, water, H2O2, HF, right? Those compounds satisfy all these two concepts. So, that means it can form not overheated. I should buy a camera, people. I should buy a camera. I should not record it with an iPhone. Like, it's not good. The camera is quality, of course, but the thing is, it's not good for the phone, right? I had to buy a camera, right? Look, these days I'm buying stuff, buying a laptop, then phone, then headset, then printers, everything I'm buying. I should buy a camera also, right? So again, went. It's not overheated, maybe not overheated. It's not overheated. Probably something wrong, I don't know. Right? So, see, hydrogen attached to fluorine, oxygen, nitrogen. The second one is lone pair on fluorine, oxygen, and nitrogen. So, those are the two things. Write it down. Okay? Yes. Right. Then, people, then let's see how are they going to form hydrogen bonds. Let's see how are they going to form hydrogen bonds. So, first example, let's see water molecule. Right? Water molecule. Between two water molecules. Between two water molecules. The first concept is there or not. Second concept is there or not. First concept is there or not. Second concept, it's a necessity, right? You need that in order to form hydrogen bonds. So first thing, hydrogen attached to fluorine, oxygen, nitrogen. Yes, available. Then it is correct. Second one, lone pair on fluorine, oxygen, nitrogen. Available. So it can. First one, hydrogen attached to fluorine, oxygen, nitrogen. Available. Second one also available. That means people, they can intercross. Actually, the bonds are formed with this one and this one. Huh? Not between 1 and 1. Not between 1 and 1. It is 1 and 2. It is 1 and 2. If this happened again, people, I will have to stop the class because I can't do this. I can run here and there. Between 1 and 2 only it forms. The other one it can form between 1 and 2 this side. It will never form in between 1 and 1. Huh? You can't make a hydrogen bond between two hydrogen atoms. You have to make a hydrogen bond with a lone pair and a hydrogen atom. That's how it's happened. Right. No, it doesn't work like that. Yeah. So this one, you can see this compound, water molecule, can form hydrogen bonds. Right? Between two water molecules, there are two hydrogen bonds formed. Between two water molecules, there are two hydrogen bonds formed. Actually, water can form four, right? It can form this lone with this lone pair, and it can form with this lone pair, and it can form with this hydrogen and this hydrogen. Actually, it can form 4. How do you see that? Look. So with this hydrogen, one oxygen is forming a hydrogen bond like this. Okay, that's it. That's it. That's the last time. This is the last time. If something happens again, I'm going to put this tomorrow. Tomorrow or sometime later, I'm going to do this class. Right. Look. Yeah. Then people, other oxygen atom will attach to this hydrogen. Will attach to this hydrogen through a hydrogen bonds with this. And people, another water molecule's hydrogen here will form a bond with this one. And another hydrogen will form a bond with this one. right? So this is the way water is forming hydrogen bonds with each other. Always one is joining with two. The lone pair and the hydrogen attached to this that atom will make a bond with each other. So this is how hydrogen bonds are formed. If you want, you can draw these two molecules and then cross it like that, and you can draw these to show how are the hydrogen bonds are formed. So if someone asks how many hydrogen bonds are formed in water, actually four, right? Four bonds are formed. H2O2, H2O2, hydrogen peroxide. Hydrogen peroxide, how many? There are six, right? If you draw hydrogen peroxide, people, there are six, right? There are six which can form. In ammonia, can you tell in ammonia how much? Ammonia, how many hydrogen bonds are formed? Ammonia. How many hydrogen bonds could be formed? Four, right? Four. I'm not going to stop today's class. I'm going to continue doing it, right? Because the plus sign comes, I don't care. I'm going to do this. Right. Okay. Calm down. Everyone calm down. Stay with me. Let's fight it. Right? Okay. I hope it doesn't come back again. The Wi-Fi is on. Maybe that's why. Bluetooth also, I don't know. Yeah. Cellular data. People who are watching the recording, people, you can skip forward these moments. Don't look at these things. Right. Let's see. Let's give it a try now. Okay. Yes. Ah, I hope it doesn't go again. Right. People, let's compare. Let's compare ketone. Let's compare a ketone. CH3C double bond oxygen. And what else would you want to compare? Hmm. Okay, let's compare a ketone and aldehyde. CH3CH2C double bond oxygen hydrogen. Right. First thing, first thing, there should be a hydrogen attached to fluorine, oxygen, and nitrogen. Another, no, right? There is no hydrogen atom attached to fluorine, oxygen, and nitrogen. The other one, next one is the lone pair on oxygen. Yes, available, right? Available. What about this one? There is no hydrogen attached to oxygen, so it is no. Second one, there is a lone pair on the oxygen atom. You can see, right? However, even if these two things are there, it will not form a hydrogen bond. Why? It cannot form a hydrogen bond between these two, right? Because this is not there. This is there. So it cannot form. So no hydrogen bonds are formed. No hydrogen bonds are formed. Makes sense, right? It makes sense. Then next one, carboxylic acid. Right? Carboxylic acid and ketone. Carboxylic acid and ketone. Right? The more hydrogen bonds it can form, the more higher the boiling point is. Right? Sometimes it is not like that. There are exceptions also. Right? First thing, what? Is there a hydrogen atom attached to oxygen? Yes or no? Is there a hydrogen atom attached to oxygen? Yes or no? Gafur? Do you want me to come and find you and hit you, right? What? If there are hydrogen atom attached to oxygen. Okay, right? Okay. Then people, first concept, take a first concept. First thing is there, right? Hydrogen atom attached to oxygen. Second one, lone pair on oxygen atom. Of course, there are many, right? 1, 2, 3, 4. This one, lone pair on oxygen is there, but the hydrogen attached to oxygen is not there. Of course, it can form hydrogen bonds, people, with 1 and 2 like this. Right? With 1 and 2, it can form hydrogen bonds, but not in the other way. So we say it can form hydrogen bonds. Can form hydrogen bonds. They can form hydrogen bonds. Right? So this is the thing. This is how you find whether it can form hydrogen bonds or not. This is how you find whether it forms hydrogen bonds or not. Hari, lazy concept, right? H2S cannot form hydrogen bonds. Why? There is no hydrogen attached to oxygen, nitrogen, or fluorine. It's a sulfur. What about H2SO4? Can H2SO4 sample form hydrogen bonds? Can H2SO4 form hydrogen bonds? Yes, of course it can form. It can form, yes. Very good. It can form. So people, the strength of hydrogen bonds, if you take the strength of hydrogen bonds, people, the strongest is hydrogen and fluorine atom. The next one is hydrogen and oxygen atom. The next one is hydrogen and nitrogen atom. Right? Hydrogen bond formation strength, the highest strength is for fluorine, the other one is for oxygen, the other one is for nitrogen. So that means, people, ammonia, even though it can form hydrogen bonds with each other, it is a gas at room temperature. Right? Ammonia is normally a gas at room temperature. If you mix it in water, then you have an aqueous. You have an aqueous solution. Right? Okay. That's it, people. Hydrogen bond formation. Right? Now, the boiling point variation. Now, this is very interesting. I want you to focus from the beginning. I know it is hard now. It's like 3 hours since we started the class. First, we did isomerism, then we completed it, and now we are doing the boiling point variation. Now, I want you to give your maximum focus. If you want, wash your face and come and sit, right? You can take a small break. I'll give you 2 minutes just to clear yourself up. If you have anything else, you have to go to the washroom or something, then do it and come, right? 2 minutes, right? 2 minutes. 2 minutes I'll give you, okay? 2 minutes. Because this is very important for you to listen. You will never mess it up again if you listen it today, right? If you understood it today, you will never mess it up. It worked. I turn off the Wi-Fi, I turn off the Bluetooth, and I removed all the other running apps. Only that app is running, and then it doesn't go to the home screen again. We have defeated the plus sign, right? We have defeated the plus sign. Powers. We have defeated. Yes. Avengers threat eliminated. Of course. Iran and Israel both, right? They cannot stay without fighting, right? They put a truce, and then what happens is somebody will hit. Somebody will hit. Even they can't stay good. That's the thing. Both Iran and Israel, right? The thing is, Iran has helped Sri Lanka a lot, as well as Israel has helped Sri Lanka a lot. During LTT, people, when America put some things against us for like showing what you call the people killing or something, they put a they filed a complaint against us, Sri Lanka. So actually, Iran helped us in that, right? Iran shouted against America in that. So Iran has helped during that time, and also people, Israel is actually that Umayyad project or something, they are doing it from their money in Sri Lanka, right? And also Israelis are there in Sri Lanka, like they are creating different cities and Arugambe and all, they are there, right? It's like their place. They are coming and staying, it's like their place. They have created the cultural thing around that place, and Israelis are there. The thing is, both the countries are like, I don't know. From my point of view, I don't support anyone. Like I want just the peace. I don't want them to fight because the leaders are fighting. Actually, leaders are underground. They are safe. I told you that day also. They are safe. Who is getting killed is innocent people, right? You might think Israel killed Iranis and Palestinians and everything. You think like they killed everyone. Okay. If you don't bring peace, and if you attack them again, they will attack you again. For sure. World War II, you remember, right? It was there in your history book. If one person retreated and said, we want peace, it's the end. Nobody will die, right? I have seen some students and people have put statuses like once they hit Iran, they are Israel, they are putting statuses like okay, they hit Israel and they are celebrating, right? Once Iran gets hit, then they are putting status like getting injured and those things. The thing is, it's not about the war, right? It's about peace. No matter who gets killed, it's humans, right? Muslims or Jews or anything. It's humans. You cannot support you cannot support when Iran hits Israel also. If you are doing that, that means you're not a good, it's not good. If you hit Israel and if you're like, if you are getting happy with it, that means that's not humanity. That's not humanity. That's not humanity, right? That is not humanity. So you can't hit it like that, right? Yes, both have, right? Innocent people shouldn't die, right? It's the thing, innocent people shouldn't die. That's my concept. If they want to fight, then tell the leaders to come into a boxing ring and fight, right? Why can't they do that? If they want to fight, just tell them to come and fight like that. If like innocent people doesn't want to riot. Even America dropped a bomb, the what do you call make a the nuclear bomb on Japan, right? In Japan, they dropped the nuclear bomb. It was dropped by USA. The people in Japan, however, the people in Japan respect USA even though they bombed them. There was a video, right? There was a video which was there on YouTube. I saw it. One person is going around the place where it was bombed and like asking people, do you respect America? Like, do you like them? Like they ask. And they don't tell anything. They don't scold. And they even have built a memorial place in Japan. So that is humanity, right? I know Palestinians died and Gaza they hit and then children die. It's not about shouting against Israel. It's about like, even though if you upload a status, it's not going to do anything. Just keep that in your mind. If you upload a status, nothing happens, right? You're keeping your studies away and then you're supporting World War. I have seen a lot of students. I didn't go and tell anything for them. My idea is like, your thing should be studies. Man, දැකලා දෙන ගොඩක් කට්ටිය. ඒ කියන්නේ I have seen like they are typing big messages and putting on WhatsApp. Actually, who will see them? Your friends, right? Are they Israelis? Tell me, right? Those who put status, come, tell me. Are they Israelis? Are they the leaders? You are just creating something within your friend group, right? Nothing will happen. The only thing which you can do is study. Once you study, you go to a big place, then you can change things. That's what I'm telling. Even if the world war happened tomorrow, you shouldn't be into it. That means you should not deviate yourself. Because even if the world war happen, you will write your exam. World war but you will write your exam. Definitely, because no one will attack Sri Lanka. You will write your exam. At the end of the day, what will among me the poll them group Iran or Israel? 60 or something has voted for Iran. I put a part for like we want peace. Only few people have voted that. What does that mean? You can think yourself. What does that mean, right? Not Israel, not Iran, it's about peace. If you think like that only, you can bring peace. You can help people. Because if you support Iran, what will happen is they will hit Israel, okay, and they will hit you back. Because America is with them, right? USA. USA is with them and Russia is with Iran. Like, huh, nobody will win, right? It's just humans will die. Right, now look, focus. I wanted to clear your mind, that's why I told that. Now look, it's 10 now. Within 30 minutes, within the next 30 minutes, you will be finishing boiling point variation. Maybe less than 30 minutes, right? So let's see. So people, if they give solids, liquids, gases, you know solids have a higher melting point, right? If a solid has a higher melting, actually at room temperature, people, there is solid, liquid, gas. Let's take for the beautiful example I2. I2 is a solid at room temperature. Then liquid is Br2, right? Br2, and then gas is Cl2. You can say, right, this guy has a higher boiling point. Definitely. Why? Because it is already a solid at room temperature. Of course, its melting point and boiling point should be higher than these two, right? Obviously. You know that. Why? Because it's a solid. So if they give you a mixture of I2, Br2, Cl2, first thing you have to do, without comparing hydrogen bonds or London forces or anything, solids have a higher melting boiling point than Br2. Br2 is a liquid at room temperature. That means its melting point is higher than the room temperature. And chlorine, it's a gas. It doesn't have a melting point even. Like, again, then Cl2 gas people. Cl2 is a gas at room temperature. If you cool it enough, then Cl2 will be liquid again. Right? Cool it. It will be a Cl2 liquid. Right? If you cool further, maybe it will become a Cl2 solid. Who knows? It can happen. Cool further. So actually the melting point is here, right? Sorry, boiling point is here. This is the boiling point. At room temperature, it's already a gas. So that's the first thing. When they give different compounds, what you're going to do is you're going to separate them into solid, liquid, gas. You're going to separate them into solid, liquid, gas. Solids have the highest melting boiling point, and then the liquid, and then the gas. Did you understand that? Hari, the first thing which you should do is separate them into solid, liquid, and gas. Every concept which you have learned until now, metallic bond strength, polarizing power, polarizability, hydrogen bonds, secondary interactions, covalent bonds, dipole-dipole bonds, whatever it is, it's coming under this note. This is a combined note for everything. So I want you to listen and focus. Tell me, did you understand? First concept, solid, liquid, and gas. Differentiating them. Did you understand? Everyone in the meeting should talk. This is serious. Yes, okay. That's the first thing. If they give you solid, liquid, gas, then people actually solid is greater than liquid is greater than gas. Okay, now people, they're asking you to compare solids. They are asking you to compare these two, I2 solid and NaCl solid. And maybe SiO2. SiO2. So you're going to compare these compounds. So solids. When you compare these three, first thing, covalent lattices have the highest boiling point. Again, melting point. Actually, melting point. Melting point highest is SiO2. Why? It is a covalent lattice. How SiO2 is the highest because it's a now first one solid liquid gas. Now we are going to simplify in between solids, between these solids, right? Comparing solids. Comparing solids, right? Comparing solids, right? Okay, everything? Right. Comparing solids. The first thing is the covalent lattices. Covalent lattices have a higher melting boiling point than the ionic lattices. Than the ionic lattices. And then the others can I2, Br2 and those things, right? I2, Br2, Br2, I2 and the other solids, right? තව එක එක solids තියෙන අනිත් වෙන වෙන ඒවා, those things, others. So covalent lattices, example SiO2, right? Example SiO2. SiO2 is a covalent lattice which has a higher melting boiling point. The other one is diamond, right? Diamond, graphite. They are covalent lattices. They are covalent lattices. They are covalent lattices. Right. They won't ask you to compare SiO2 and diamond. Diamond very, you know, right? Diamond is large. Ionic lattices, people. Ionic lattice क्या हम मुकदमा मत करने. NaCl, MgCl2, MgS, MgO, EI, MgO. Bingo, right? NgO, right? That is NgO. I'm talking about MgO, magnesium oxide. Right? Magnesium oxide, magnesium sulfide, magnesium chloride, sodium chloride, potassium chloride, ionic lattices. When you want to compare ionic lattices, what was the concept that you put forward? Come on. What was the concept that you put forward? What was the concept that you put forward? When you talk about ionic lattices, මොනවද දැම්මේ? මොකද concept එක? What was the concept? Polar, what? Polar, type it, come on. Polar, rising power and other one? Polarizability, right? Polarizing power and polarizability. That is polarization, yes. Polarizability and polarizing power. That thing we put forward, right? Polarizing power and polarizability. Using these two concepts, we combine them together and we compared ionic nature. We compared ionic nature. When ionic nature high, melting point is high. When ionic nature is high, melting point is high. And then people others, example I2 solid. Right, I2 solid. On tamai people, we have to face when you're comparing solids. Covalent lattice, ionic lattice, and then others. Right? Covalent lattice, ionic lattice, and then others. Okay. Then boiling point variation again, you might ask why I'm teaching melting point. People isela melt karanne pa boil karanne ne, you can't directly go from, you can go, but that's a different situation. I'm telling if you are like solid to liquid gihillan gas yanne ne. Arama yanda පුළුවන්, right? You can go like that. It needs different pressure conditions. At room pressure, at room temperature and pressure, you can't do that. Right? Okay. Then we will comparing solids, that's all. Comparing solids, that's all. Write this and let me know. Write this and let me know. Write this and let me know. Done, eh? Everyone done? Everyone done? Right. Okay. Now I'm going to erase the board. Now, next one. Comparing liquids or solutions. Comparing liquids or solutions. Next is solid liquid. Ne? So now we are comparing liquids. Comparing liquids. Right. When comparing liquids, people, you have to look at secondary interactions. The only thing which you consider here is secondary interactions. In the tube, people, you have 2 pages to write. I won't think it will take that amount of pages, right? But if you want to write big people, then you can write. You have enough space, right? Okay, then, yeah. So when comparing liquids or solutions, yeah, you have to compare about secondary interactions. Right? Secondary interactions. එතකොට ඒකේ priority order එකක් තියෙනවා. Right? Secondary interactions වල priority order එකක් තියෙනවා. එක තමයි when someone is having iron dipole is stronger, iron dipole is stronger than dipole. හරිද? Iron dipole interactions කියන්නේ මෙහෙමයි. Like sodium plus and water molecule like this, delta minus and hydrogen. This is not a hydrogen bond, people. It is much stronger than that. This bond is much stronger than that. Iron dipole, sodium plus and water molecule, right? Sodium plus and water molecule. After iron dipole, you have dipole. Actually, dipole comes later. You get hydrogen bonds. Hydrogen bond is a type of dipole, but I'm writing it separately. Hydrogen bonds. You know hydrogen bonds, right? After that only comes what? After that only comes dipole. That means one water molecule, a hydrogen bond. Let's take another one. Dipole. Between CH3Cl and CH3Cl, like that, right? Just dipole. Then after that, you get iron-induced dipole. Iron-induced dipole. Iron-induced dipole. කියන්නේ like sodium plus is going to alter the. Now this is non-polar, right? This is non-polar. This doesn't have any polarity, but this one has a polarity. So this is iron dipole. This is iron-induced dipole. You're inducing a charge. Like Br is coming to a sodium plus, and then it's going to change its shape, and it's going to give it a negative sign. Right? It's going to give it a negative sign like this. You can imagine this. Br2 is floating like a Tom and Jerry. In the Tom and Jerry, like the, what do you call, Jerry is flying towards the cheese like that. ඇවිල්ලා sodium plus ළඟට ඇවිල්ලා එයාගේ අර electron cloud දෙක altered, right? His electron cloud is getting altered. So what will happen is මෙන්න මෙහෙම වැඩක් අනිත් පැත්තට ඉන්නනේ. Right? So it will pull the electrons towards him, right? It will pull the electrons towards him. So what will happen is this iron-induced dipole interactions are created. So that is stronger than dipole-induced dipole. Dipole-induced dipole. Right? It is stronger than dipole-induced dipole. Dipole-induced dipole කියන්නේ people, water molecule is inducing a charge in a compound like Br2. Right? Br2 is non-polar, same like this. In this case, a ion is inducing it. In this case, a dipole is inducing it. H2O is a dipole. It is inducing a charge in Br2. So that is ion dipole induced dipole. The last one, the name might sound very unfamiliar and very hard. Instantaneous induced dipole moment. And dipole interactions. Instantaneous induced dipole interactions. මොකක්ද? London forces. අර දිග වචන කියන්න ඕනේ නෑ people. Dipole මේ London forces. Or you can write LDF. London dispersion forces. I read London dispersion forces. London dispersion forces. Instantaneous induced dipole interactions. Right? Draw this. So when comparing liquids, you have to respect this priority order. There are some situations which doesn't obey this. I'll tell that later. So this is the order which you have to respect when comparing liquids or solutions. So then comes the hydrogen bonds, the ion dipoles, and then dipole-dipoles, ion-induced dipoles, right? All of these come into play. Right. Everyone finish writing? Everyone finished writing? Finished writing? Nah. Iron dipole එකට පිටිපස්සෙන් එන hydrogen bonds. ඊට පස්සේ dipole. ඊට පස්සේ තමයි ion induced dipole. Right. Then people, I'm going to erase the board. Right. Now people, we are going to, then මෙහෙමනේ. Two molecules can have same amount නේ. ඒ කියන්නේ මෙහෙම. Like this. ඒ කියන්නේ same amount of forces, same interactions they might have. CH3 CH2Cl and CH3 CH2 CH2Cl. මේ දෙන්න. When comparing these two, මොනවද තියෙන්නේ දැන්? Dipole තියෙනවා. Right. Dipole is there. He also has dipole. Another thing is London dispersion forces තියෙනවා. London dispersion forces කියන්නේ මොනවද? Right? What are London dispersion forces? It's like this. One Br2 and another Br2 is approaching each other and they will run because they are scared of each other, something like that. They are coming like this, bouncing off and going away. So that is London dispersion forces. He also is a non-polar compound. He also is a non-polar compound. So he's coming together and going away, creating a charge and then going away, right? Bouncing and going away, right? So it happens overall from different molecules. So that is London dispersion forces. So that London dispersion forces depends on two things. London dispersion forces depends on two things. I'm going to erase the board. London dispersion forces depends on two things. London dispersion forces, right? LDF. LDF depends on molar mass. This is the first priority. Right? This is the first priority. And then the surface area. Then the surface area. First the molar mass, then the surface area. So when comparing London dispersion forces between two molecules, first you have to compare what? Molar mass. Let's say you want to compare helium and xenon. Helium and xenon, who has the higher melting point? So it doesn't have dipole and anything not there, right? Only London dispersion forces are there. He has electron cloud. He also has electron cloud. They approach each other and form London dispersion forces. So London dispersion forces depends on what? Molar mass and surface area. The surface area method look very many people. Xenon has a larger molar mass. When someone is heavy, it's hard to lift him, right? When someone is heavy, people, it's hard to lift him. So the boiling point is high. මූගේ බර වැඩි වුණා මූ යන්න බෑනේ people. Just imagine, right? The fat someone is staying inside that and you have to pull him out. It's hard, right? So the boiling point is high. First, you have to compare molar mass. If the molar mass is same, then the surface area. If the molar mass is same, then the surface area. For example, this one. For example, CH3, CH2, CH2, OH, right? CH3, CH2, CH2, OH, and CH3, C, CH3, CHOH. This one. This one and that one. Molar mass same. Why? Isn't they are isomers? They are isomers, and their molar mass is same. The same structural formula. Surface area. People who has a larger surface area? The branched one, no unbranched one. The branched one, no unbranched one has a larger surface area. No, not no, not branched one. Unbranched one has a larger surface area. Okay, මතක තියාගන්න මෙහෙම people. Now, if you give a child a clay ball, clay, something you give him a clay, right? A big pot of clay, like this handful of clay you give him. You tell, and you give paint. You give some amount of paint. You ask that child to prepare the shape that will take the least amount of paint to paint it. You tell the child to prepare a shape that will take the least amount of paint to paint it. It will be a sphere. It's a sphere. Sphere has the least surface area. Sphere is the one which has the least surface area. So when something is spherical, it will take a smaller surface area. When something is oval like this, when it is straight, it has a larger surface area. Did you understand? The small, when you are just free, just imagine. Sphere has a low volume, right? Low volume, low surface area. Lower external surface area. And then imagine we are taking that sphere, we are just you are creating a cylinder. Now you have a larger surface area. Why? You used a lot of clay inside it to create the surface. Did you understand? Did you understand? Hiten nati way, but it's the truth. Some of you might not get it, but it's the truth. The sphere has the lowest surface area. If the sphere has the lowest surface area, then the surface area is larger in this one. That means he has the higher melting point. Sorry, boiling point. He has the higher boiling point. That is how you compare. That is how you compare. That is how you compare. And one more thing, both of these form hydrogen bonds, right? Both of them form hydrogen bonds. So that is how you compare people. When surface area is high, boiling point is high. When molar mass is high, boiling point is high. The priority should be for molar mass. That's the first one. The priority should be for molar mass, and then it should be for surface area, right? Then it should be for surface area. Then it should be for surface area. Put two examples there. As I told you, CH3, CH2, CH2, OH. And then CH3, CH, CH3 OH. So that is more spherical than this. And this has more surface area. So there you can write same molar mass. If same molar mass, then you move into the other one, right? Surface area, same surface area. No, right? He has a larger surface area. CH3, CH2, CH2OH has larger surface area. This guy has a larger surface area, right? Hurry. AKMI. Second one. You're comparing helium and neon. Neon has a larger, what do you call? Melting point, right? So that means boiling point. So boiling point. That means helium and neon can molar mass of neon is larger than that of helium. That is why it has a larger melting point, a boiling point. Finish writing? Taggala ලියන්න. Taggala people, quickly write. Right. Right. Now, people, we are going to exceptions. We are going to exceptions. We are moving to exceptions, right? So these are small exceptions which you need to know. So first one, very large molar mass. Very large molar mass. So let's consider this compound CH3, CH2, 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 CH2OH. And you're comparing it with CH3, CH2, Cl. You might say, Aya, you told me a priority order. I was looking for the priority order. I checked, like, this person can form hydrogen bonds. He can form hydrogen bonds and he can only form dipole-dipole. He can only form dipole-dipole. But what you didn't know is this person is very big. No one can help this guy. He's very big. He's too fat. Because of that high molar mass, because of that very high molar mass, people, he gets the higher boiling point. He gets the higher boiling point. Right? He gets the higher boiling point. What's the reason? Very large molar mass. Very large molar mass. Actually, when molar mass is greater than 100. Molar mass greater than 100, we ignore sorry, මේක අනිත් පැත්ත එන්න ඕනේ. මෙයාට මෙහෙම දැම්මහම හරිනේ. Now the explanation goes well. Look. What do you expect, right? What do you expect, right? This is what you expect. What do you expect? That guy should have a higher boiling point. That guy has a higher boiling point. That is what you accept. Why? Because that person can form hydrogen bonds. And this guy can form only dipole-dipole. right? He can form only dipole-dipole. You expect that person to be the one with the higher boiling point. You expect that person to be the one with the higher boiling point. But actually, this person is very large. Because of that, he has a larger boiling point. That is what I wanted to tell. Molar mass is greater than 100. We ignore hydrogen bonds in the opponent. That means you are doing a comparison. So we are doing a comparison. If the molar mass is very big people, he can't even fight with him. Right? So the opponent we ignore. We ignore the opponent. Because he has a very large molar mass. Maybe not greater than 100. 1, 2, 3, 4, 5, 6. Yeah, greater than 100. Right? So we ignore the hydrogen bonds in the opponent. So we don't care about it. We don't care about it. Did you understand? මේ concept එක තේරුණාද? හරිද? මේ concept එක තේරුණාද? මේ concept එක තේරුණාද? Nice. So even now London dispersion forces dominates more than dipole and even hydrogen bonds. You can see that, right? When the molar mass is very high. So it all makes sense now. Does it all make sense? Are a solid comparison එකේ people? Yeah. No. Okay, fine. Yes. නේ? හරිනේ එතකොට? When surface area high, molar mass high, London poses high. Then, yeah, priority order site all. And then people fourth on gases. Comparing gases is same as comparing liquids. Comparing gases, same as liquids. Gases you should compare same as liquids. Because why? Why is that? People. When you convert liquid to gas, you call that what? Boiling. You call that the boiling point. Boiling point. When you convert gas to liquid, you call condensation. Does it have a condensation point? No, we don't talk about it. It's just the boiling point. Same thing. Condensation point. You have the melting point. Right? Fusion point. That's the thing. Right. Yeah. That's it. That's it, people. So let's do some examples. Let's compare some people, right? Let's compare and see, right? Okay. So compare these compounds, will you? So organic boiling point variation, let's focus. You have to compare CH3, CH2, CH2, OH, and CH3, CH2, C double bond oxygen, OH, and then CH3, CH2, C double bond oxygen, chlorine. And maybe CH2, CH2, OH. And CH3, CH2, Cl. Yeah, that's it. And the ether, let's put an ether also. This one. Right. Compare this. Compare this. Hurry. Let me compare now. So let's see. People, when you have a carboxylic acid, you can see the amount of hydrogen bonds formed is large, right? See, this lone pair can form hydrogen bonds, this lone pair can form hydrogen bonds. So that's 1, 2, and here this hydrogen can form, this oxygen can form, and this oxygen can form. There are 1, 2, 3, 4, 5. 5 hydrogen bonds can be formed. 1, 2, 3, 4, 5. Yes. 5 hydrogen bonds can be formed by carboxylic acid. Right? 5 bonds can be formed. What about this one? 1, 2, only 3, right? Only 3. That one also only 3 hydrogen bonds. This person doesn't form anything. It's like just like an alkane, but dipole has an but still it's like negligible. He has the least melting point, least boiling point. Then he's the next one, right? So it's like this: CH3, CH2, OCH3. It's the least. And then you have this compound, CH3, CH2, Cl. Then you have highest one is this, CH3, CH2, C double bond oxygen, OH. He is the highest one. Then who is in middle? This one and that one. Who now both of them have hydrogen bonds. Both of them have hydrogen bonds. So whom do you expect to have a larger boiling point? A or B? A or B? A or B has a larger boiling point. B, right? Yes. B. Why is B? Because it has a larger surface area. Larger surface area, actually larger molar mass, right? You can see larger molar mass. It has a large, greater London dispersion forces. So therefore, CH3, CH2, CH2, CH2OH. And then you have this CH3, CH2, CH2OH. That's it. Hurry, right. People, I'm going to stop it from there. I'll drop some work for you to do, maybe within tomorrow. Why did ether come at last? Because you have to consider ether as just an alkane. Again, okay, ලොකු එහෙම මුකුත් නැහැ. කියන්නේ මූට dipole හදනවා. But still it doesn't make any effect, people, like this. Right? මෙයා තරම් effect එකක් දෙන්නේ නැහැ. This one is weak than this, even alkyl halide, it is weaker than that. So due to that reason, people, he has the least boiling point. He has the least boiling point. මෙයාගේ යන්නේ 12 point ගානක්, මෙයාගේ 9 point ගාන. ලොකු වෙනසක් නැහැ, but still he has a larger melting point. Sorry, boiling point. It's due to dipole-dipole interactions, the level of dipole-dipole interactions they are talking about here, right? Okay, people, then you can leave the meeting now. I will upload both of these recordings to YouTube as a video. Anytime you can watch until the exam, it is going to be there, right? You can revise this part as much as you want. It's going to be there on YouTube, free for everyone, public, right? Okay. Thank you for joining, people. See you again in the next class. We have another class on Saturday night, most probably Saturday night or Sunday night. One of those 2 days we have, right? So next week we are going to do, on Saturday we are going to do the rest of the organic tute as well as chemical kinetics, right? Okay, bye-bye. Good night.